Let's move on to the question number 7. This is question number 43 actually. So question number 43 says that consider a pyramid located in the first octant where XYZ are positive, O is origin. So let me draw the diagram. Here O is origin, O is somewhere here, and OP and OR along x-axis and y-axis respectively. Base OPQR of pyramid is a square, so it's a square pyramid with OP equal to 3. So point P is on x-axis, so this point will be 3, 0, 0, and point R is here. Point R is 0, 3, 0. So obviously point Q, OPQR is a square, right? So point Q will be this point, and this point is 3, 3, 0. Now it says that point S is directly above the midpoint T of diagonal OQ. So let me draw the diagonal OQ, and midpoint of this diagonal OQ is T. So point T is here. What are the coordinates of point T? That's 3 by 2, 3 by 2, 0. And point S is above this T. Okay, so somewhere above this T at a distance of 3 from here. So what are the coordinates of point S? Coordinates of point S will be 3 by 2, 3 by 2. X and Y will remain same. Only Z will increase because I'm moving in Z direction. So this will be the coordinates of point S. Now we need to find out so many options, right? So that's first option is acute angle between OQ and OS. Alright, so OQ, vector OQ is nothing but 3i cap plus 3j cap and 0k cap, right? So no k component. And OS is nothing but 3 by 2i plus 3 by 2j and 3k. Now if I want to find out angle between these two components, then that's cos theta is equal to, I can just use a dot product OS dot OQ divided by magnitude of OS and magnitude of OQ. So from here if I solve this, I get 3, so 9 by 2 plus 9 by 2 plus 0 divided by magnitude of this 2. So that's 3 root 2 magnitude of this vector, and magnitude of this vector will be under root of 9 by 4, 9 by 4. So that's 9 by 2 plus 3 square, that's 9. So if I solve this, I get 9 divided by 3 root 2, and here I'll get 9 common, so that will become 3, and under root of 3 divided by under root of 2. So this will get cancelled. 3 into 3 is 9, so I'll get 1 by root 3. So theta will be equal to cos inverse 1 by root 3, which is not as per the option. So this option A will not be correct. It's given pi by 3, it will not be pi by 3. Equation of plane containing O, Q and S. S is somewhere above this point T, and this plane will be actually y equal to x plane. Yeah, so that's correct, right? X minus y equal to 0. If I consider this plane which is coming outside the board, right? So this plane is obviously y minus x equal to 0 outside the board. So that's the correct option. B is correct. Length of perpendicular from P, where is point P? Point P is here, and from this point to OQS. OQS is this, so this perpendicular distance I want to find out. I want to find out this perpendicular distance. Let me use different colors. Yeah, so this perpendicular distance will be nothing but, we can just use this point and this line we can use, right? This is y equal to x line, so just put the point. I'll get 3 minus 0 divided by 3 minus 0 divided by under root of 1 square plus coefficient of x square plus coefficient of y square, right? So here 1 and here minus 1, so 1 square plus minus 1 square. So this perpendicular distance will be 3 by root 2. That's correct. So this option is also correct. And perpendicular distance from O to straight line RS. Now where is RS? This point is R. Point R is 0, 3, 0, 0, 3, 0, and S is 3 by 2, 3 by 2, 3. So what will be equation of RS? Equation of line RS, we can write something like this: x minus 0, y minus 3, and z minus 0, and divided by 3 by 2 minus 0, so that's 3 by 2, 3 by 2, and 0. 3 by 2 minus 0, 3 by 2 minus 3, sorry, here. So I'll get this, and this is equation of RS, and to this we need to drop a perpendicular from O. So let me suppose this as lambda. So if I suppose any general point on this line, so that will be 3 by 2 lambda, comma 3 by 2 minus 3, so that will be 3 minus 6 by 2 minus 3 by 2, so minus 3 by 2 lambda plus 3, and comma lambda. Alright, this will be a general point on this RS, and now I want to find perpendicular distance from O. So let me say this point is some point A. Alright, so OA square, this will be 3 by 2 lambda whole square plus minus 3 by 2 lambda plus 3 whole square and plus lambda whole square. And now this distance should be minimum, right? This is perpendicular distance, so this distance should be minimum. So we can like differentiate and minimize this, find out the value of lambda, and then you will get the minimum distance. So simplify this, and so we can just directly differentiate also, right? And then find out the value of lambda. So if I differentiate, what I'll get, or maybe you can do the calculation part now. All you have to do is differentiate, find the value of lambda, and for that value of lambda again put back in this equation, you will get OA. And I think that will come out to be same as the option which is given here. So this option will be the correct option. It will come out to be root of 15 by 2 if I solve it. And let's move to question number 8. Question number 8 says that in a triangle XYZ be the length of opposite sides. So there's a triangle like this. Triangle is XYZ. This is small x, this is small y, and this is small z. These three lengths, and it is given that 2s is equal to x plus y plus z. So actually s is semi-perimeter, and it's also given that s minus x divided by 4 is equal to s minus y divided by 3 is equal to s minus z divided by 2, and the area of the incircle is 8 pi by 3. So we have to check for the following options. So area of incircle, if I assume in radius to be r, let us assume that in radius is small r, then pi r square will be equal to pi into 8 by 3. So from here I can surely say that r square will be 8 by 3. Now we also know a formula that r is nothing but delta by s. This is the formula that we have studied in solution of triangles. R is equal to delta by s. Okay, now let's do one thing. Let's consider this to be lambda. Alright, so I can say that s minus x will be 4 lambda. Also I can say that s minus y will be 3 lambda. Also I can say that s minus z will be 2 lambda. Now if I add all the three equations, I get 3s minus x minus y minus z, that's 2s, and this will be equal to 9 lambda, right? So from here I'll get s equal to 9 lambda. Now if s is 9 lambda, what will be the value of x? Put in this respective equations. So I'll get x equal to, from this equation I'll get x equal to 5 lambda, y is equal to 9 minus 3, 6 lambda, and z is equal to 7 lambda. These are the values of x, y, and z, which are the sides. Now once I know the sides, I can easily find out area of triangle, that's delta. So what will be delta? By Heron's formula we can write down that. So this is delta into s minus x, s minus y, and s minus z. So what is s? If I add all three, right, so x plus y plus z, so s is nothing but 9 lambda, right? S is 9 lambda. 9 lambda into s minus x is 4 lambda, S minus y is 3 lambda and this is 2 lambda. So find out under root of this quantity. That will be uh, from here I get 3, this is 2, 3 to the 6, 6 root 6 lambda square. This will be delta. Okay, so what will be small r? Small r is actually delta by s. So this is 6 root 6 lambda square divided by s. S is 9 lambda. So lambda lambda will get cancelled. 3 2s are and 3 3s are. So I'll get 2 root 6 divided by 3 into lambda. This is r. Okay, if this is r, we know that r square is equal to 8 by 3. We know this. So if I square this, I'll get 4 into 6 divided by 9 into lambda square. This is equal to 8 by 3. Okay, now if I simplify this, I get 4 into 2, and then this will be 2 into 3, and from here I'll get lambda square equal to 1. So lambda equal to 1, right? Because sides are positive, so I'll not consider lambda as minus 1. All three sides of triangles are positive, so lambda is plus 1, and if lambda is plus 1, I can find out everything. So what will be delta? Delta will be, area will be 6 root 6. What will be r? R is already given, right? R square is 8 by 3, so r will be under root of this. What else we need to find out? We need to find out radius of circumcircle. Alright, so that's capital R. Capital R is also known to us, that's ABC by 4 delta, right? Here actually it's XYZ. So this XYZ divided by 4 times delta. So XYZ, what are X, Y and Z? That's 5, 6, 7. So that's 5 into 6 into 7 into lambda cube divided by 4 times delta square. Delta is actually 6 root 6. So we can square this, or maybe we can put in terms of lambda only. So what is delta in terms of lambda? That's okay, so 6 root 6 square, that's 36 into 6. Okay, and lambda is just 1, so this will just get cancelled. 6 cancels. So basically I'll get r as 35 divided by 4 into 36. This will be capital R, which is not correct. This one is not correct. So then sine of x by 2, sine of y by 2, and acha, we also know this. We also know that small r is actually equal to 4r sine x by 2, sine y by 2, and sine z by 2. So the value of this quantity actually will be r by 4r. So we can find out from here. Now actually I know r, I know capital R, so I can find out the value of r by 4r. And this part is sine square x plus y by 2. So sine of x plus y by 2, I can write it as 180 minus z by 2. Alright, so and square of this, so this will be nothing but cos square z by 2. Now if you remember the half angle formulas, from half angle formulas we can say what is cos square z by 2. Cos square z by 2, so this will be s into s minus z divided by xy. Now you can simply, you know all the three values in terms of lambda, you can put and get the answer. S is actually, s is 9 lambda, s minus z also you know this too also, so we can just simply put and we can find out the answers. Alright, so I think this option will also come out to be true, so you need to check for these two options and find out the values. So I told you the method, you can find out the answer. Okay, let's do question number 9. That's question 45 actually in the paper. So that is, if let rs be the diameter of the circle where s is the point 1 comma 0. Okay, so rs is something like this. There is a circle which is x square plus y square is equal to 1. So this is the circle. So this is x square plus y square equal to 1. Point S is this, which is 1 comma 0, and RS is diameter, so R will be this point will be minus 1 comma 0, and point P is a variable point, so point P is somewhere here other than RS, and tangent to the circle at S and P meets at Q, so I'll draw tangent at point P. Tangent at point P is like this, and tangent at point S is like this. So this two will meet at point Q. Alright, so let me consider this point in parametric form. So this will be cos theta comma sin theta. So what will be the equation of tangent? Equation of tangent we can find out, and that will be nothing but what is the curve? X square plus y square is equal to 1. So if I find out the slope, that will be nothing but 2x plus 2y dash is equal to 0. So from here y dash is minus x by y, so which is nothing but minus of cos theta by sin theta, and that's minus cot theta, right? So y minus y1 is equal to minus of cos theta by sin theta and into x minus cos theta. So this will be the equation of tangent at point P. Alright, so this is the equation of this line actually. So sin theta into y minus sin square theta, this is equal to minus cos theta into x minus minus plus cos square theta. This sin square theta, if I take it to the other side, I'll get plus sin square theta, and that will become 1. So actually I'll get sin theta into y plus cos theta into x is equal to 1. This is equation of tangent. And what is equation of tangent at S? At S, x equal to 1. This will be the equation of tangent. So let me find out point Q. X coordinate will be just 1. So put x equal to 1, I'll get y equal to 1 minus cos theta by sin theta. So this point is actually 1 minus cos theta divided by sin theta. This is point Q. Now I need to find out what is next. Let's read the question. The normal to the circle at P intersects the line drawn through Q parallel to RS. Alright, so there is a normal at point P. What will be the equation of this normal? Equation of this normal is, here slope is minus cot theta, right? So here slope will be just sin theta by cos theta, tan theta. So this line will be y equal to tan theta into x. It's passing through origin. This is equation of normal, and equation of line which is parallel to RS from Q, right? So that will be this line, and this line will be y equal to, equation of this line is y equal to 1 minus cos theta by sin theta, right? Y coordinate of Q, and this point is given to be E. So y coordinate will be same, we just need to find out the x coordinate, right? So this point is h comma k. Now if I solve these two lines, what I'll get? If I solve these two lines, I'll get the x coordinate, and that's 1 minus cos theta divided by sin theta, and this is divided by tan theta, right? So divided by sin theta, and here cos theta, this will be x. So this is nothing but 1 minus cos theta into cos theta divided by sin square theta, and this is x. 1 minus cos theta divided by sin theta, yeah. So we know the value of h and k. This is h. H is nothing but 1 minus cos theta into cos theta divided by sin square theta, and what is the value of k? K is 1 minus cos theta by sin theta. So 1 minus cos theta is actually 2 sin square theta by 2, and this is 2 sin theta by 2 cos theta by 2. So this will get cancelled, sin theta by 2 will get cancelled, so k is actually tan theta by 2. Okay, so what will be x? This is tan theta by 2, right? So x will be directly tan theta by 2 divided by tan theta. Yeah, so h, not x. H will be tan theta by 2 divided by tan theta. And k is tan of theta by 2. Now we need to find out relation between h and k somehow. So we know that tan theta will be equal to 2 tan theta by 2 divided by, actually I can just divide this two equations. So from here h will be k by tan theta. Okay, so tan theta will be actually k by h, and this is 1 minus tan square theta by 2. So theta by 2 is k divided by 1 minus k square, and this is k by h. So k will get cancelled. So actually I'll get 1 minus y square equal to 2x. 1 minus y square equal to 2x. One minus y square equal to 2x. Now you can just simply put all these points and check which all points are lying on this curve. So we just need to substitute all these points and check which all points are lying on this particular curve. So once you have the curve, it becomes pretty easy. We can solve it. So I think that's a pretty easy task. You can do this. Yeah, we can go to question number 10. That's question 46 in the paper. So that's x square plus y square is equal to 3. This is a circle which is given with center at O, intersects the parabola x square equal to 2y. So again let's draw the diagram. So this is the circle. Parabola is something like this. X square equal to 2y. This point is O. P in first quadrant, so this point is P. Let tangent to C1 at P touches other two C2 and C3 at R2 and R3 respectively. So let's find out point P first. So if I solve this to x square plus y square equal to 3, and x square is 2y, so y square plus 2y minus 3 equal to 0. So I'll get y plus 3 y minus 1 is equal to 0. So y will be 1. Y can't be minus 3 because it's given first quadrant, so y will be 1. If y is 1, then x will be root 2. So this point is root 2 comma 1, both in first quadrant. So point P we got it, and now it's given that let tangent to C1 to this circle at P touches. So let's write down the equation of tangent to C1 at point P. It will be something like this. This is tangent. So equation of tangent will be, what is the curve? The curve is x square plus y square is equal to 3. So let me find out the slope. That will be 2x plus 2y y dash is equal to 0. From here y dash is minus x by y and minus root 2 by 1. So slope is minus root 2. So equation of tangent will be y minus y1 equal to minus root 2 into x minus x1. It will be something like this. So y plus root 2x is equal to minus minus plus, so plus 2 plus 1, this will be equal to 3. This is the equation of tangent, and it's given that, so this line is y plus root 2x is equal to 3, and now P touches the other two circles C2 and C3 at R2 and R3. So there are two more circles actually which are here, and their radii are also same. So one circle will be something like this here, and the other circle, this is this line. If I extend it, it will be like this, and this tangent, if I extend it, it will be like this. Other circle will be somewhere here because the radii are same. So this again touches, and it's having this particular circle. This particular circle is having equal radii Q2 Q3, and this Q2 Q3 lies on y-axis. So their centers, they lie on y-axis. All right. So if I let me extend this. So two circles will be actually like this. If I show you diagrammatically, one circle will be like this, center is there on y-axis, and the other circle will be like this, and both of them are of equal radii. So they are touching the tangent, and so somewhere here this is Q2 and this is Q3. But no need to go into the detailed diagram. We can just simply take the center of one of the circles as 0 comma some y, and then we know that perpendicular distance from this center to this tangent will be equal to radius, and we know the radius is equal to, if I drop perpendicular from this center, this is 0 comma y, and this will be equal to radius. Radius is given to be 2 root 3. So if I drop perpendicular, I'll get y minus root 2 times 0 minus 3 and divided by under root of 1 square plus root 2 square, and this is equal to 2 root 3 mod of this. So actually I'll get y minus 3 is equal to 2 root 3, and this is 2 plus 1 root 3. So this multiplied by root 3 and mod of this. So I get y minus 3 mod. If I open the mod, I'll get plus minus, and this is 6. So there will be two values of y, that's 9 and y equal to minus 6 plus 3 minus 3. So those 2 points, Q2 and Q3, they are actually nothing but, one of the point is 0 comma 9 and the other point is 0 comma minus 3. These two are the points, and radii are already given, that's 2 root 3 radius of both the circles. Small r, we can use small r. Now what we need to find out? We need to find out Q2 Q3. So what will be this distance Q2 Q3? It will be of course 12. So that's correct option. Q2 Q3 is correct. R2 R3. R2 and R3 are the point of contacts, right? These 2 points. This point is R2 if this is Q2, and if this is Q3, this point of contact is R3. So we need to find out the point of contacts as well. So basically we need to find out the foot of perpendiculars, and you know the formula for foot of perpendiculars also. So from these 2 points we need to find out foot of perpendiculars. So the formula, we can use that. What is the tangent? Tangent is y minus root 2x minus 3 equal to 0. So what we can do is we can just use the formula like this: x minus 0, y minus 9, here I'll get minus root 2, here I'll get 1, and this will be minus times of, put the point. If I put the point, I get 0, x is 0, y is 9, so 9 minus 3, and divided by root 2 square plus 1 square, so that will be 3. So from here if I solve, I'll get x equal to, this is how much? This is actually equal to 6 by 3 2, so that's minus 2, right? So 2 root 2, x equal to 2 root 2, and y equal to minus 2 plus 9, so that's 7. So 2 root 2 comma 7, 2 root 2 comma 7, and the other point also we can find out similarly. By using the same formula we can find out the other point. So that other point will come out to be, I can just use here x minus 0 by minus root 2 and y plus 3 by 1, and this will be minus times, put the point. If I put the point, I'll get x is 0, so y is minus 3. So minus 3 and divided by 3. So that's minus 6 divided by 3. So this will be 2. So x will come out to be minus 2 root 2, and y will come out to be minus 1. So minus 2 root 2 minus 1. Actually wait, there was a plus here, so this will be plus, and here also it will be plus. So this will be minus and this will be plus. Yeah, so two points are R2 will be minus 2 root 2 comma 7, and R3 will be 2 root 2 comma minus 1. These two are the points, R2 and R3. So I got those 2 points also, R2 R3, and now we just need to find out area of triangle OR2 R3. That we can find out by using determinant formula. So that we can just write it like this: 0 times origin, then 2 root 2 minus 1 1, and here I can just write 2 root 2 7 1, and we need to just simply find out the value of this determinant. So if I find out the value of this determinant, it will come out to be 6 root 2. So this will be the correct answer. And again, this, the coordinates of P, I know the coordinates of Q, I know the coordinates of Q3. So again, you can use determinant formula. This area will also come out to be 6 root 2. So this is not a correct option. D is not correct. A is correct. C is also correct. And R2, R3. That also we can find out by using distance formula. I know both the points, so just apply distance formula and find out R2, R3, and check whether that distance comes out to be 4 root 6 or not. Actually, I think it will come out to be 4 root 6, but still check it once.